Hi guys, I hope you are well. I hope you are healthy. Um, my name is Sarah Tamizi, and we are going to be discussing about chapter 4, Biocatalysis of your Biobooster booklet. All right. So before we start, I would just like to remind you or inform you that this chapter will contribute about 6 marks to the total of 80 marks of your final exam paper. All right, so let's begin. Okay, I hope everyone can see my screen. Okay, so we go to the first question. Figure 1 shows the rate of reaction for a particular reaction with enzyme and without enzymes. So the first question asks you define enzyme. So this is a typical question. All right, definition. So you should be able to define, okay, by right, the definition of enzyme. All right, so enzyme is a biological catalyst, okay, 1 mark, or organic catalyst that speed up chemical reaction, another 1 mark, by lowering the activation energy. So there are 3 options there, but the maximum mark is 2 marks, all right? The second question is describe the 2 curves in figure 1. All right, so when the question asks you to describe something, okay, especially this question asking you to describe the graphs. So basically, describing question does not require in-depth kind of understanding about a particular thing, okay? So you just have a look at the diagram and then you describe the diagram, okay? For example, like this one, okay? So the reaction with enzyme proceed rapidly as the substrate concentration increases and reaches maximum where it remains constant, all right? So even without learning biology, okay, you know that if it's a graph for rate of reaction, okay, the speed of rate of reaction is shown by the steepness of the curve, all right? So the first curve, the red colored curve, is the curve with reaction with enzyme. So compared to the reaction without enzyme, so the curve for reaction with enzyme is steeper compared to the curve for reaction without enzyme. So quickly we know that the reaction with enzyme proceeds faster or rapidly, okay, as the substrate concentration increase, okay? So just reading the graph, okay? And then it will reach a maximum rate where it remains constant, okay? So you just read the graph, all right? And so that's 1 mark, okay? Because you described one graph, and then now it's time to describe the other graph, all right? The reaction without enzyme proceed at a much slower rate as the substrate concentration increase, okay, as compared to the reaction with enzyme, and it will not achieve the same maximum rate as the reaction with enzyme, okay? All right, as I have mentioned earlier on, there is no background kind of like understanding about enzyme. You just simply read or describe the graph, okay? So that's what describe question requires you to do. All right, and then the next question, explain how the active site of enzyme helps in lowering the activation energy. All right, so we know that enzyme speed up chemical reaction by lowering activation energy. So, so we also need to know how the enzyme lower the activation energy. All right, so by bringing the substrate closer together into correct orientation, so that's 1 mark. All right, so we know that you already learned in chemistry that in order for a chemical reaction to happen, okay, the substrate not only need to collide with each other at the right energy, but also need to collide at the right orientation. But because of enzyme have active site that act as a mold, bertindak sebagai acuan, so when the substrate come together, they will of course come together in the correct orientation. So unlike reaction without enzyme yang kena langgar sekali tak semestinya at the right orientation, but with enzyme disebabkan oleh active site dia bertindak sebagai acuan. So when the two substrate comes together, memang confirm masuk dalam right orientation. Okay, alright, and then enzyme will facilitate the breakdown of old bond. 1 mark. Enzyme will also facilitate the formation of new bond. Okay, and enzyme also stretch or stress um, or distort the bond. So there are several options here, okay, that you can choose to, okay, to help you get the full marks. Okay, all right. Now, question D: sketch 2 labeled curves in the space below to show the effect of adding A, a competitive inhibitor, and B, a non-competitive inhibitor into an enzyme catalyzed reaction. First of all, I would like to apologize because there has been some mistake during the editing of the booklet. So you get a different graph. So this is actually the graph that you should get in your booklet, an empty graph. Okay, all right. So this is the empty graph that you should get. All right. So we know that with a non-competitive inhibitor, we know that with a competitive inhibitor, okay, as we increase the substrate concentration, all right, so the rate of reaction will increase, okay, until it eventually reach the same maximum as the reaction without inhibitor. Okay, so this is graph A, okay, reaction with competitive inhibitor, all right, and this one, okay, this is the graph for non-competitive inhibitor, reaction with non-competitive inhibitor, all right? So we know that because they do not compete for the same active site, no matter how much substrate you add, as long as the non-competitive inhibitor is there, okay, your substrate cannot bind to the active site, reaction will not occur, all right? So that's why for the non-competitive inhibitor, the rate of reaction will not achieve the same maximum, okay, as the rate of reaction without inhibitor, no matter how much substrate you add. All right. The next question is, give two differences between competitive and non-competitive inhibitor. So the first one is that competitive inhibitor have similar shape to the substrate. Meanwhile, non-competitive inhibitor does not have similar shape to the substrate. So that's 1 mark. Okay, so take note that I have already formed a full sentence, okay, and I have highlighted the word meanwhile, so you can use meanwhile, but however, okay, so make sure that you use those comparative terms, all right. So and then the second answer is the competitive inhibitor binds to the active site, okay, of the enzyme. Meanwhile, non-competitive inhibitor binds to the enzyme's allosteric site. So basically, there are two criteria where you can compare. So the first one is the shape of the inhibitor with the substrate. You compare those two, and then another criteria that you can compare is the where it binds. Okay, the location where it binds. All right. So settle the first question. So the second question is, figure 2 shows a model to demonstrate the mechanism of enzyme action. Sorry, give me. So name molecule S, T, and V. So we know S is substrate, T is enzyme, and V is product. So you need to get all answers correct, and then you will be awarded by 1 mark. Okay, so name the model shown in figure 4 and explain. All right, so the model is induced-fit model or induced-fit hypothesis, 1 mark. And explain why do you say that this is induced-fit model. Okay, all right, so this is because the shape of the active site is not exactly complementary or fit with the shape of the substrate. Right, so 1 mark for that one. Okay, predict what will happen to the formation of U in the presence of a reversible inhibitor. So what is U? We know that U is enzyme substrate complex. So because of there is a presence of reversible inhibitor, okay, so that's why I put the first answer to be the first answer, I guess the first choice. All right, so less U will be formed for a given time. Okay, or the second answer is U cannot be formed. Okay, so I prefer the first answer. Okay, because this is a reversible inhibitor. Okay, alright. So kita kepada soalan yang seterusnya. Okay, so the next question B2. State 2 types of reversible inhibitor. Okay, and explain how they interact with enzyme. Okay, to decrease rate of reaction. Okay, so as you can see, all right, so the first one is competitive inhibitor, and I got 1 mark underlined. So meaning you have to mention, okay, competitive inhibitor, okay, and then explain. And then I'm going to mention non-competitive inhibitor, and then baru explain. So kalau awak tak ada tulis perkataan competitive inhibitor ataupun non-competitive inhibitor, okay, maka wajib tu, okay, yang lain-lain kami tidak tanda. So jadi basically orang maka kosong markah. Okay, alright, so you have to mention competitive inhibitor, okay, baru boleh ditanda. Okay, alright, so let's have a look. So the first one is competitive inhibitor. Alright, satu markah wajib. So since it has similar shape to the substrate, it competes with the substrate for the same active site. Binding of the competitive inhibitor to the active site prevents binding of substrate into active site to form enzyme subject complex. So kita tahu, okay, competitive inhibitor dia akan bind kepada active site. Kita tahu sebab dia bentuk dia sama macam bentuk substrate kan. Okay, so dia akan compete for the same active site. So dia akan bind to the enzyme active site. So bila dia bind dekat situ, substrate tak boleh masuk. So, bila substrate tak boleh masuk, tidak terbentuk enzyme substrate complex. So jadi tidak berlaku reaction, tidak dapat product. Okay, so that's how it slow down. Ataupun that's how competitive inhibitor decrease the rate of enzyme action. Okay, so that's the first mark. Okay, so saya tahu dia punya markah dia, saya tahu dia punya jawapan dia panjang. Okay, but the objective of Biobooster is for us to discuss. Okay, for us to discuss, and not for you to tanda-tanda ni lah. Okay, tanda-tanda macam exam. Okay, so macam ni. When I was a student, I will, kalau soalan tu soalan explain, I will explain sampai habis. Okay, why? Biarlah dia jadi macam panjang pun, why? Okay, satu, because I know that it's my paper, it's my mark. So, so it's my mark, so tulis je lah. Okay, no one else gonna add marks except for myself. Okay, itu benda yang pertama yang saya fikir. Benda yang kedua saya fikir adalah saya akan study for essays. Okay, saya akan study for essays because bila kalau saya study essay, all of the information already in my head, keluarlah soalan apa pun, saya ada information dekat dalam kepala saya itu. So jadi saya tinggal tulis sahaja. Tak kisahlah soalan tu soalan essay. Kalau soalan essay mestilah saya boleh jawab kan, sebab saya dah hafal ataupun saya dah study for essay. Okay, but kalau keluar soalan struktur pun saya boleh jawab because all of the information dah ada dalam kepala otak saya. Okay, alright. So don't be scared or whatever. I understand. I once on your level. Saya pun dulu student metric juga. Okay, alright. So that's the first one, competitive inhibitor. Okay, so the second one is non-competitive inhibitor. You mentioned that 1 mark. Okay, maka wajib. Okay, bila awak ada mention tu, baru saya akan tengok kepada explanation. Alright. It binds to the allosteric site of an enzyme. Okay, and induces conformational change in the enzyme's active site, thus preventing substrate from binding to enzyme active site to form enzyme substrate complex. 1 mark. Okay, alright, so it's fairly simple. So kita tahu macam mana punya non-competitive inhibitor buat kerja lah. So dia akan bind kepada allosteric site, causing the active site to change conformation. So punya substrate no longer fit into the enzyme active site. Enzyme substrate complex is not formed, reaction cannot occur, so product cannot form. So that's how your non-competitive inhibitor decrease the rate of enzyme reaction. Okay, so settle for that question, and then let's have a look at the last question. Name another model that explains the mechanism of enzyme action and describe how it differs to the one in figure 4 pula. Okay, dalam figure yang tadi tu lah. Okay, dalam figure dalam figure 2, dalam figure 2 lah. Okay, so the model is lock and key model ataupun lock and key hypothesis. Okay, alright. Saya tahu lock and key hypothesis tak ada dalam kita punya syllabus, but since you have already learned in the secondary school, so I just include in the question. Okay, so that in case a question is being asked in the exam, you at least know a little bit about the lock and key hypothesis. Okay, you remember. Okay, so kita just ulang kaji sajalah daripada SPM level. Anyway, so the name of the model is lock and key model ataupun lock and key hypothesis, 1 mark. Itu adalah markah wajib perlu disebut. Okay, barulah kami tengok kepada jawapan-jawapan yang seterusnya. Kalau itu tak disebut, kami tak akan tanda langsung soalan C itu. Alright, so how does it differ from the figure 2, iaitu apa ni, induced-fit hypothesis? Okay, the enzyme active site is exactly complementary to the substrate. Okay, so itu adalah benda yang paling senang nak ingat lah. Okay, right. So the enzyme active site is exactly complementary to the substrate. Okay, 1 mark. Alright, so maksimum dia adalah 2 marks. Okay, so yang penting kena tulis dulu model dia adalah lock and key model, 1 mark, and then satu lagi markah untuk penerangan. Okay, so penerangan yang paling simple untuk diingat adalah the enzyme active site is exactly complementary to the substrate. But there are also other comparison that you can compare. Okay, seperti yang di bawah tersebut, the enzyme active site is not flexible, okay, or enzyme active site will not change shape to better fit the substrate, okay, or enzyme active site does not change back to original shape or conformation when the reaction has finished. Okay, so these are the other examples of explanation that you can write down, okay, in case if the question asks. Okay, so just several options. All right. Okay, so settle for structured questions. So let's have a look at essay questions. All right. So with the aid of diagram, explain mechanism of enzyme action based on induced-fit hypothesis. So based on my experience, okay, you have to you have to practice with this drawing. Okay. Because kalau diberi soalan drawing secara tiba-tiba, okay, awak tak buat practice, so awak akan kelam kabut lah. Okay, especially untuk case of induced-fit hypothesis, I have experience with my students yang lukis tak apa-apa. Okay, so let's try. Okay, and we we identify what is the problem. Okay, ketika melukis awak punya induced-fit hypothesis. Alright, so that you not going to make mistakes if question like this come up. Alright, so pertama sekali, bila awak lukis apa induced-fit hypothesis, awak kena ingat bentuk substrate tidak berubah. Okay, bentuk substrate tidak berubah, bentuk substrate kekal. Okay, yang berubah cumalah bentuk active site sebelum, semasa dan juga selepas. Okay, so sebelum dan juga selepas, okay, so sebelum bentuk asal lah kan. Alright, selepas reaction, dia akan kembali kepada bentuk asal lah, betul tidak? Alright, semasa tu, okay, semasa reaction berlaku, while enzyme substrate complex is formed, so bentuk active site akan exactly fit with the shape of the substrate. Alright, so as you can observe in the diagram. Alright, so gambar tak perlu kompleks. So this is the example of diagram that I found online. Okay, so gambar tak perlu kompleks. Alright, yang penting awak akan tahu mana satu yang berubah. Okay, pastikan ada label. Okay, pastikan ada label awak punya diagram tersebut, substrate, enzyme substrate complex, okay, enzyme product. Okay, so kena pastikan ada label. Alright, dan apa lagi yang saya nak sebut? Okay, untuk reaction ini, yang ini adalah reaction pembinaan di mana dua substrate bergabung menjadi satu. Okay, reaction anabolic. Okay, tetapi kalau awak nak buat reaction pemecahan, katabolic reaction also fine, terpulang, tak ada masalah. Okay, yang penting bentuk enzyme tu, okay, sebelum, kemudian semasa dan juga selepas dapat berubah. Okay, that's very, very important. Alright, so let's have a look at the answer. Induced-fit hypothesis suggests that the active site is not exactly complementary to the shape of the substrate. Okay, the active site is flexible and can change its shape. When substrate collides to enzyme, it can bind to enzyme active site. Binding of substrate to the active site of the enzyme triggers the conformational change in the enzyme's active site. Okay, typical. Alright, benda yang kita dah belajar, benda yang simple. Alright, so this enables the enzyme active site to bind the substrate precisely. Okay, thus enzyme substrate complex is formed. Alright, so bila dah membentuk enzyme substrate complex, barulah berlaku reaction. Okay, barulah enzyme tolong reaction tu berlaku. Macam kita belajar tadi lah, macam kita jawab tadi. Structures, stress, okay, the bond. facilitate breakdown of bond, facilitate formation of new bond. Okay, gitu. Alright. Enzyme stretches the existing bond to facilitate the reaction to occur. Okay, and then product is formed and released from the active site. The enzyme changes back to its original conformation, return to its original conformation pun boleh. Yang penting membawa maksudnya sama. Alright, so 10 marks. Alright, so kita tengok kepada soalan yang berikutnya, soalan yang terakhir, soalan yang terakhir. By sketching a graph, soalan sketching. Okay, discuss the effect of temperature on the enzyme reaction. So bila kita tengok kepada sketching a graph, okay, dia punya values tu tidak berapa penting. Kalau nampak saya bagi okay. Alright, so by sketching a graph, by sketching, bukan scratching. Sketching garu. Okay, so by sketching a graph, discuss the effect of temperature on the enzymatic reaction. Okay, so dia punya values is not very important when sketching, but the shape must be correct. Okay, dan jangan lupa when you do a graph, jangan lupa dia punya axis. Do not forget to label the axis. Alright, so axis yang X adalah temperature, okay, degree Celsius, and axis Y adalah rate of reaction. Okay, so jangan lupa the axis. Alright. So at low temperature, the enzyme reaction is slow. So kita tahu at low temperature, the enzyme reaction is slow. This is because molecules move very slowly. Okay, this is only chemistry. So kita tahu at low temperature, okay, molecules move very slowly. Therefore, the rate of collision, kadar pelanggaran, okay, the rate of collision between substrate and enzyme active site is slow. Okay, dah dia bergerak perlahan. Kadar pelanggaran pun sedikit lah kan. Alright, so hence kalau dia tak berlanggar, kadar pelanggaran dia rendah, so rate of formation of enzyme substrate complex also occur at slow rate. Okay, alright. Thus, kalau ESC tidak terbentuk ataupun ESC forming at slow rate, so product pun also akan terbentuk at slow rate. Thus, causes product also to be produced at slow rate, thus slowing the enzymatic reaction. Okay, so as the temperature rises, enzymatic reaction become faster. Seperti kita tahu, as temperature rises, chemistry okay, as temperature rises, rate of collision, okay, molecules will start to move faster. So the rate of collision between substrate and enzyme active site, okay, will increase. Okay, so baca balik, as temperature rises, enzymatic reaction become faster. This is because molecules start to move faster. Alright, therefore the rate of collision between substrate and enzyme active site increases. Hence, formation of enzyme substrate complex also occur at a higher rate. Okay, alright, causing more product to be produced at a given time. This gives the overall result of faster enzymatic reaction. Dah banyak produk terhasil per given time, so rate of reaction awak naik lah kan? Betul tak? Alright. For every 10 degrees Celsius increase in temperature, the rate of reaction is doubled. Okay, so this information is very important when you are building or sketching your graph. Alright, so disebabkan the rate of reaction dia double every increase in 10 degrees Celsius, so graph dia akan naik ala-ala exponential gitu kat sini. So nampak tak dia macam naik macam exponential sikit, because every 10 degrees Celsius increase, the rate of reaction akan double. But dia punya rate of reaction tu tak akan sentiasa naik je. Okay, dia akan capai maksimum dia. Okay, alright, dia tak akan sentiasa naik. Jangan awak naik sampai 40, naik 50, naik 60, awak ingat rate of reaction dia naik juga. Okay, double juga, not necessarily. Okay, sebab tu dia kata dekat sini, for every 10 degrees Celsius increase in temperature, the rate of reaction is double. However, this is only true until the optimum temperature of the enzyme is reached. Okay, dicapai. So optimum temperature, apa maksud optimum temperature? So optimum temperature refers to the temperature at which the enzyme action is at the maximum rate. Okay, so itu adalah contoh ayat yang saya bagi, tapi yang penting awak boleh tulis apa-apa saja ayat definition optimum temperature, definition of optimum temperature yang sewaktu dengannya. Okay, alright. So further increase in temperature beyond this point ataupun beyond the optimum temperature will no longer increase the rate of reaction. Okay, so this is because the high temperature will break, okay, various bonds that hold the enzyme in its shape. So kita tahu, kita dah belajar daripada sem lepas, there are 3 bonds, there are 2 interactions that will keep enzyme in its conformations. Kita ada ionic bond, hydrogen bond dengan disulfide bridge. Okay, so itu yang disebut dekat sini sebab kita cerita pasal bond. Soalan kata pasal apa ni? Ayat tu cakap pasal bond. Dan dalam ada 2 lagi interaction, iaitu hydrophobic interaction dan juga van der Waals interaction. Alright, so basically for temperature, boleh sebut kelima-lima benda tu akan break down. Okay, too high temperature. Okay, so too high temperature will break all those things. 3 bond, ionic hydrogen dengan disulfide bridge, and then 2 interaction, iaitu punya van der Waals interaction dan juga punya hydrophobic interactions. Okay, boleh sebut semua akan breakdown kalau too high temperature. Okay, alright. So tapi ayat dalam Biobooster dia kata this is because the high temperature will break various bonds. Kalau bonds ada 3 lah. Okay, that hold enzyme in its shape, such as hydrogen bond, disulfide bridge, and ionic bond. Ingat, so saya cakap tadi, ingat kelima-lima. Kalau temperature memang akan ganggu kelima-lima benda tadi. Alright, so thus causes the enzyme to lose its shape ataupun to lose its conformation. Dah semua bond yang memegang enzyme tu dalam bentuk dia break. So jadi tak ada enzyme tersebut akan terurai lah. Okay, hilanglah bentuk dia. Okay, the enzyme is said to have been denatured. So bila enzyme dah denatured, okay, substrate can no longer fit into its active site. Thus, the rate of reaction decrease. Alright, so that's all for this session. Okay, I wish you good luck for everything. So I'll see you when I see you. Hi guys, I'm sorry. Satu lagi, saya nak tekankan shape of your graph. Saya terlupa nak sebut. Alright, I would just like to emphasize on the shape of your graph, okay? Because when it comes to graph, ada 2 graph yang boleh ada possibility untuk disuruh lukis. Satu graph temperature, and another one is graph for pH. Kalau graph pH, yes, dia boleh jadi bentuk macam bentuk normal distribution curves, okay? Boleh, tak ada masalah. That is for your pH graph. Okay, but for temperature graph, bentuk dia jangan lukis macam normal distribution curve. Jangan bentuk bell shape. Kalau bentuk bell shape, awak lukis untuk temperature, salah. Okay, kalau graph untuk temperature, since kita tahu every increase in 10 degrees Celsius, dia punya rate of reaction akan double macam ni. Okay, so yang belah sini, okay, dia akan naik lebih kurang macam awak punya exponential growth curve. Okay, dia akan condong sikit dekat sini. Kemudian dia akan capai optimum temperature. Alright, kemudian selepas saja optimum temperature, rate of reaction dia akan slow down. Okay, and then eventually disebabkan oleh temperature dah jadi terlampau tinggi, dia punya bonds yang memegang di dalam dia punya shape dia akan breakdown, so enzyme akan denature, so jadi tak dapat lagi nak melakukan reaction. Okay, sebab enzyme dah denature, so dia punya rate of reaction dia akan terus jatuh merudum. Okay, so graph dia akan jatuh merudum kat sini. Okay, sebab tu, okay, jangan lukis untuk temperature, jangan lukis bentuk macam bell shape. Okay, normal distribution, salah, kena bentuk macam ni. Okay, alright, so good luck, thank you.